Ladies and gentlemen, good evening. I'm Diego Aisa. I'm an export manager of a company which produces building chemicals. And I am very happy being here. Thank you for inviting us through our partner Sintecno. Sorry for speaking in English, but the alternative option would have been Italian, which I guess is even worse. So let's get started. A few words about the company. KIMIA has been founded back in 1979, and it's been specialized since the very beginning, since the foundation, in the production of traditional and innovative materials for repair of historical monumental buildings as well as reinforced concrete structures. We have a wide range of case histories done in Italy and abroad. As you have been already told, the main topic of my presentation would be to give you an idea of a practical feedback we gathered from the behavior, the structure previously reinforced with different strengthening systems shown under a seismic attack. Because, as you know, in Italy we have had, and especially in the area where our company is located, plenty of earthquakes during the last decades. And so we have seen what happened with the repairs done after the earthquake which struck Italy in 1979 and afterwards in 1997 and lately in 2016. And we found out some interesting information about the strengthening systems applied and about the behavior of the systems applied in time. Because every time we are working in retrofitting an existing building, we also have to take into account that what we are doing is not going to stand only for 5 years, but will stand in time. So we also have to take into account what will be the durability of the systems applied, their compatibility with existing buildings in time. After last earthquake in 2016 in our region, we found out that there were some recurring problems, and we will go through them quickly. One typical problem we have seen has something to do with the disintegration of walls, which were actually very poor quality walls in time. And we noticed that maybe in the previous earthquakes some injections were performed, but still these walls wouldn't behave in the correct way, since, for instance, like in the bell tower of Santa Maria la Bianca ad Ancarano or in Campi in Orcia, these walls were not injectable ones. So the Italian regulation were pushing a lot the use of some interventions like injection for curtain walls, but if you applied these systems in walls which were not injectable, the systems applied wouldn't behave in the correct way. In fact, you see that the injection mortar is not actually has not been able to fill the gaps, the voids, because the wall were not a cavity wall with interconnected cavities to be injected, so it was not injectable. The issue we had in Italy over the time is that after earthquakes which struck Italy in 1979, for instance, injections were typically done also with cement slurries. And this resulted in chemical reaction with original materials. So, okay, we have a problem because if we decide to make an injection, for instance, we have to make sure that the walls we are injecting are injectable, but we also have a problem, that is to say, what is the chemical nature of the material we are using? Is that correct? Will it be able to guarantee in time the compatibility, the chemical compatibility with existing materials? So the results after many years of application and sometimes of injection with wrong materials were that often the cement-based slurries would react with gypsum originally contained in the walls to create materials like etringite and taumasite, which would have no actual strength and which will damage the original walls instead of increasing their resistance. Many problems are also related to the lack of connection in case of curtain walls, walls that have cavities inside and they have only two faces, which plenty of time are not very well connected. So applying connections in case of cavity walls resulted in bettering a lot the behavior of the original masonry, and this is something that we have experimented also after last earthquakes. One intervention which proved to be very effective in increasing the overall behavior of masonry is the repointing. You see a couple of buildings. One has been very well repointed after 1997 earthquake, and the other one has not been repointed. It's seen that a good repointing is an effective way to at least make so that the masonry won't explode, but will activate the typical mechanism of collapse, standard damages mechanisms, and not the explosion. So you see here an example, a direct comparison among deep repointed and non-repointed masonry. Of course, they were different buildings, but it is something that we are now considering very important in order to increase the original resistance of the masonry mortars. But another problem again rises. Okay, let's say that it is very important that we deep repoint the walls so that the overall behavior of the walls will be the best possible. What material am I using? Again, in the past, sometimes the idea was the strongest, the better. So I will use a cement-based mortar, which is the strongest product maybe. And so the idea was I'm increasing a lot the original resistance of the walls. But some problems arose, like you see here. If I use a cement-based mortar, okay, I have a problem with the chemical compatibility, as we have seen so far, but also cement-based mortar are less permeable to water than natural hydraulic lime-based mortars. This results in water standing more in the repointed areas in case of a natural hydraulic lime-based mortar, and freeze-thaw cycle so will damage more the mortar instead of damaging the bricks or the stones. If I used a very strong, less permeable product as a cement-based mortar, of course, the water will try to stand inside the more permeable element, that is to say, the brick. So freeze-thaw cycles, instead of damaging the repointing mortar, will damage the stones and the bricks, creating a very big damage in the original material. So repointing, but using the right products, compatible, chemically speaking, and physically speaking, with existing materials. Plasters without previous deep regrouting, like in this private house in Visso, shown very poor behavior under seismic attack, and mostly without the deep repointing, applying a plaster over an existing historical low-quality wall will result in having no structural strengthening and in detachments of the new plaster very easily. An alternative option is collaborative plasters, which are reinforced with nets and connected to the substrates. Again, in the past, sometimes the idea was the strongest the better, as I said, so some cement-based plaster were used. And we obviously understood that increasing the stiffness with a plaster, which could sometimes also not be very well connected to the original masonry, wasn't a good idea. And in any case, some problems will arise because of the fact that the steel meshes will in time tend to corrode. So nowadays we are developing some second generation collaborative plasters based on the use of alkali resistant glass fibers. So we have no problem with corrosion as it happened with previous collaborative plasters, applied with natural hydraulic lime based mortars. So we overcome the problems dealing with the chemical compatibility, stiffness, etc. we have been discussing so far with cement based plasters. So this is a system we are now testing and certifying also in terms of design, procedure, certification of systems. Italy is moving in this direction. Other typical problems we found out over the last few earthquakes. We saw that sometimes they didn't like to see tyrants to secure the horizontal behavior of arches. And we have two examples of two different churches, San Martino de Gualdesi and San Piero a Vallinfante, in which in the first case they got rid of the tyrants and the structure had major failures, while here with a church with a similar construction, similar geometry and similar situation, as you see, tyrants were still there and they had no problems in times. So sometimes we got rid of structural systems only because they were old or they were not fashionable, but we didn't replace with more effective systems, and this resulted in worsening the behavior of the original building. Sometimes they kept the structural systems that were meant to retain the walls for collapsing, for instance, like in this case, but they didn't check what was the status of these wooden trusses that were actually avoiding the tower to open. And they found out that the wood was completely faded, and these metallic anchors they could see from the outside were actually just somehow completely detached from the faded wooden beam. So lack of connection is a big issue because of the local movements that will be allowed in case of, earthquakes. What we have done in the previous intervention repair after earthquakes which struck Italy in late 70s, early 80s, for instance, sometimes was to secure the connection applying some ring beams at the level of the floors or at the roofs, which actually were sometimes built destroying part of the masonry. So the system would, in a subsequent earthquake, behave like this. So we have a very rigid, stiff system and the wall have been weakened in order to make room for these new buildings, and a lot of collapses are connected with this kind of structural devices. Some options may come to help and have been applied prior the last earthquakes and proved even during earthquakes to behave in an interesting way. For instance, SRG, steel reinforced grout. So there are second generation composite systems which, instead of using carbon fibers and resins, will use as tensile phase metallic fibers, galvanized or stainless steel, applied together with mortars. So we don't use epoxies for this kind of application, for instance. And this can be somehow applied to replace ring beams in order to avoid collapse of walls out of their plane. And again, these solutions can help in case of lack of connection of walls and roofs. Whether in the past, often some ring beams, reinforced concrete ring beams were widely applied, they proved with the last earthquakes not to be a very best solution, given the fact that they are subject to sliding among the existing wall and the ring beams, the concrete ring beams, due to the lack of connection maybe, or maybe they did some connection, but they were grouted in the core of the curtain wall, so without any actual grouting. So a lot of times it's possible to see the walls collapsed under the weight of and the stiffness of the reinforced concrete ring beams applied afterwards. These systems, in many occasions, also in last earthquake, proved not to be effective. Here you can see the steel rebars which were meant to connect the reinforced concrete ring beams to the existing walls, and you see nothing good over there. But an alternative solution could be the use of a composite material which is built up, joining together the wall, the bricks, the masonry, and reinforcing it using SRG systems so as to create a material which, as in concrete, we couple a material which resists to compression, the concrete, with the rebars for tension, and we gain a material with a flexural resistance. In the same way, it's possible to join the bricks, the masonry, which will react mainly withstand compression, with these steel fibers withstanding tension, so as to create a beam which will have flexural resistance, but will result in something less stiff than a reinforced concrete ring beam, with fewer problem in terms of connection with existing walls, of compatibility, mechanical, physical, with the existing building. So this proved to be a very interesting option to solve some problems that in the past we used to solve with different, more stiff and less compatible solutions. This was my last slide. I thank you for your attention, and if you have any questions, I'm yours.